This is a CCEA Mathematics M7 Paper 1. It's from the November Theory Series 2022 and from Thursday the 1st of December. So let's take a wee look then at our question 1. A sequence consists of rectangles and circles as shown. Complete the table for patterns 2, 3, 4 and 7. So obviously number of rectangles 1, 2, 3. So 3 there, 4 there, and you can see 1, 2, 3, 4. So obviously we're going to have 7 rectangles then for that. The number of circles, so in the first one then we have 4. In the second one we have 1, 2, 3, 4, 5, 6. And then 8, and hopefully you can see then it's going to be 10 for pattern 4. There's going to be 4 here, there's going to be 4 here, that's 8, 9, 10. And again, I'm not sure if you can kind of see the pattern here, so I guess we're going to have 7. So there's going to be 7 going across here, 7 goes across here, 14, 15 then, and 16. The total number of rectangles and circles, so we're just adding here 2 plus 6, and gives me 8, 3 plus 8. Gives me 11, 4 plus 10 is 14, and 7 plus 16 then is 23. Which pattern number has a total number of 38 rectangles and circles? So I guess we're looking for either an nth term, as it would be called, or some sort of way of working it out. So I would put it by the nth term. So we're looking at the total number of rectangles and circles, and it's this formula here. So that goes up, add 3, add 3, add 3, and so on. There's a gap between that one and that one. So my formula then is going to be something of the form 3n. We substitute the number 1 into the formula. 3 times 1 gives me 3, but I want 5, so it's 3n plus 2. So for example, say I wanted to know how many were in the fourth, I put a substitute in the number 4. 3 times 4 gives me 12 plus 2 is 14, so it does seem to work. We're going to do this the other way around, so 3n plus 2 equals 38. Take away 2 from both sides, 3n is 36, and we get n then equals 12. So it should be the 12th term then that's that amount. Question 2. A distance time graph shows a train journey. It looks like it's going from Bangor to Lisburn, so distance travelled down in miles and that. What's the distance between Bangor and Lisburn? So it starts at Bangor, 0 miles, and then up here it looks like it's 15, so it looks like it's heading here. So I think our answer then is going to be 17 miles. Give a reason for the horizontal line which starts when the train reaches Lisburn. So we have this, so maybe it's time to allow passengers to disembark or something like that, or the train arrived early at Lisburn just to stop then from there, so something like that. Train stops, give time for passengers to change, or something along those lines. Hopefully that makes sense. The train leaves Lisburn and travels on to Lurgan. The distance between Lisburn and Lurgan is 13 miles and the journey takes 15 minutes. Show this information on the graph. So it's 13 miles and 15 minutes. So 13 miles added on into here. So we're at 17 here. So hopefully you can see that's going to take us in up to 30. So we're going up to this line here and it's 15 minutes. So that looks like it's 9:04. So let me see if we can work out then how this is going to fit on just about. So that would be 5 minutes, that would be 10 minutes, and that then would be 15 minutes. So it's going to be round about there. So it looks like it's leaving then at 9:04. Hopefully you can read that off, because that would be 5, 10, 15 as we have here, and 15 minutes after that is then 19. So with our ruler then we're going to join our straight line up here. And that's that journey. Show this information on the graph. What's the average speed of the train from Lisburn to Lurgan? And that's in miles per hour. So as it says, it travels 13 miles in 15 minutes. A few different ways of working this out. So speed is distance over time. So our distance then is 13, but our time isn't 15. Remember, it's in miles per hour, so this needs to be in hours, and so then that would be a quarter. So 13 divided by a quarter is the same as 13 times 4, and in that case then it would be 52. So 52 miles an hour. Another way of working it out, and this is maybe more intuitive, I suppose, but if it travels 13 miles in 15 minutes, how far is it going to go in 60 minutes? You would times that by 4, so you times that by 4, and that would give you 52 miles per hour. Give one reason for knowing that the graph shows average speed rather than actual speed. So for example, then speeding up and slowing down, you can't start at full speed, so it shows no stops. So what does that mean? Where's my graph? It's disappeared on me here. It wouldn't actually kind of go like that. You would kind of start slowly, so it would actually kind of be a curve until it hits its speed, and then it goes a wee bit quicker and stuff like that. It's the fact then it's a straight line. So just for example, speeding up or slowing down, we can make that work. All right. Ross works out that 200 times 90 is equal to 18,000. Write down a calculation Ross could use to check his answer. Well, he could just do kind of either of the two the other way around. So for example, he could do 18,000 divided by 90, or you could have a divide sign in there, and we could cancel out that. Then 1800 divided by 9, so it changed to a 2, and that then would give us 200, for example. That might work. On to question 4. Obviously we're non-calculator here, so 5% of 45. I could do it a couple of different ways. You can go 5 over 100 times by 45, and that would work it out. I'm tempted to find 10%. 10% is quite straightforward. So 10%, I hope most of us realise, and it's going to be 4.5. So what's half of 4.5? Hopefully we can see then 5%. 4.5 divided by 2 is going to be 2.25, or 2 1/4. So my answer then would be 2.25. Charlie has drawn a sketch of a trapezium with lengths and angles as shown. AB is already drawn, so that's drawn below. Using a ruler and protractor, complete Charlie's trapezium accurately. So we need to do a 60 degrees here and an 80 degrees here. So we need a protractor then for this. So we set up then our 60. So as accurately as you can, you want this point here to be exactly on their A, and it means you have more chance of getting full marks here. And it's 60, so I'm going from 0 here along this line, and that then would be up to 60. I'm going to do a nice light line, and then we're going to measure 6 centimeters after that. Again, as accurately as I can. Nice light line, which is way more than 6, but that's okay. So let's measure then 6 centimeters. Again, as accurate as I can get it. And measure off the 6 then from there. The other one then is 80 degrees, so we need to measure then the 80 degrees here. So we're going then from the other side again, right on B, as accurately as you can do it. And we're going up then to 80 degrees here. So there's my mark. And then we're going to try and draw a line as parallel as we can going across in here. If you're feeling particularly fancy, you could actually measure your angle. I don't know if people realize that if that's 60, then that would have to be 120 if this is going to be a parallel line there, and that's what we have. So that's our AB, that's our D, that's our C, that's our 60 degrees, and that is our 80 degrees there. Question 6, 60% of entrants pass a test. What is the ratio of number who pass to the number who fail? give your answer in the simplest form. So we could just do then 60 to 40. I know we don't know how many there are, but it doesn't matter. We know the ratio is going to be 60 to 40. I can see very clear that divides by 10. So that would be 6 to 4. And then that cancels down again from 3 to 2. The ratio of boys to girls born in a hospital 1 week is 3 to 5. What fraction are girls? So make sure we get this one the right way around. So it's boys to girls is 3 to 5. There are 8 parts here, 3 plus 5. So it's out of 8ths. So the fraction that are girls then is going to be 5/8. Question 7. At the beginning of January, an oil tank was 3/4 full. At the end of March, it was 1/6 full. What fraction of the tank was used? And you've got to show you're working. So we got to do 3/4 take away a 1/6. It's quite hard to see that that's the calculation required, but that's what it is. So I'm going to change this into 12ths. We need a common denominator. So I'm going to times top and bottom of this one then by 3. So that gives me 9/12. Take away 2/12. 9 take away 2. And we have 7/12. Question 8. Transformations one then. So it's hard to fit this on the screen here, but draw the image of shape A after a translation 7 right and 4 down. Label it T. So we can pick a couple of points and move them along 7 and down 4. So let's count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Take another point. This one here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Again, if you want to pick the other two, so some people can see the shape now and kind of draw it on. Sometimes you're better just being careful. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And then the final one I can see that is going to be here. So nice and thickly with your pen that you'd be using. You want to mark it on like this. And it says to label this shape. Let me see, I think it was T. Label this shape T. And that's us. Draw the image of a shape A after a rotation 90 degrees anti-clockwise about the origin. Label it R. So the way we do our rotations is to use then some tracing paper. I have some here. Let me see if I can get rid of the previous thing that's on it. Okay, so it's actually greaseproof paper from the kitchen, but that's okay. So it's about the origin. That's my dot there. And then you might be better using a ruler here, but I'm just going to go freehand in for the minute. And if you can set it up, I wouldn't be setting the paper at an angle. I know mine's a bit jiggly kind of top and bottom here, but I would be kind of trying to make it either like portrait or landscape. Then it's much easier to see if you've rotated 90 degrees. So let's rotate this round. I'm putting my pencil here, and I'm going to rotate this round 90 degrees. And I can see then it seems like it's going to be landing here. So my pointy bit then of that is -3 -2. So let's do my point there. If I need to go back, I can check some other bits and pieces off, but I can see then that that's going to be the shape then that I require there. Again, make it nice and clear to the examiner where exactly your shape is. Nice thick lines. And that then has to be labelled R. And that's us finished off then from there. On to question 9. P is a polygon. The sum of all the angles P is 3 times the sum of the angles in a quadrilateral. How many sides is P? The sum of all the angles in P is 3 times the sum of the angles in a quadrilateral. So in a quadrilateral we have 360 degrees, and so 3 times 360, you can do it whatever way you want. Just do a wee multiplication if you're not sure what that gives you. 360 times 3 is 0, 18, is going to be 1080. So we need to see then how many sides that has. So you can use your formula if you want, or you can just kind of work your way up. So I know, so you could use the formula 180 upon n minus 2. That tells me the angles in it, 18080. The other option is, we know, hopefully everybody knows, that a three-sided shape of triangle is 180 degrees. So you just keep going up and adding 180 each time. 4 is nothing, is 360. 5 is another 180, so it'll be 540. 6 is 720. 7, another 180, is 900. And then 8 is another 180, so that's 1080. So my answer then would be 8. A couple of different ways of doing that. I sort of did it a bit of a long way, but hopefully that makes sense. Question 10. A shape has a perimeter of 16 centimeters and an area of 10. It is enlarged using a scale factor of 2. What is the perimeter of the enlarged shape? Well, the perimeter is going to double because it's kind of the length of the sides. So it's going to be scale factor 2. So it's going to be times by 2. It's going to be 32. How many times bigger is the area of the enlarged shape than the area of the original shape? It doesn't actually ask you for an answer, but it just wants to know how many times bigger it is. So this is to do with our kind of ratios. If the sides are in the ratio 1 to 2, that's what scale factor 2 means, then the areas are going to be in the ratio 1 squared to 2 squared. So that's obviously 1 to 4. So it's then going to be 4 times bigger. In this particular one, the area then would be 40. Another polygon question then. Each interior angle of a regular polygon is 140. How many sides has the polygon? So I would find the exterior angle. So remember, the exterior angles kind of look that sort of thing. So if that's 140, then the exterior angle is going to be 40. It's regular, so those are all 40s, and always the exterior angles add to 360. So if we do 360 divided by 40, we end up then with 9. So it must have 9 sides. Question 12. The diagram shows a section of coastline with a lifeboat station marked at B and a lighthouse marked at L. So that's it there. We'll come back to that. A sinking ship sends a distress signal. The ship is less than 70 kilometers from B and less than 30 kilometers from L. Using a scale of 1 centimeter to 10 kilometers, shade the region of which the ship could be. So if it's less than 70 kilometers from B, we need to set our compass here to 7 centimeters. Do you see what I've done there? So I've kind of changed that. 1 centimeter is 10, so 70 then would be 7. So I'm going to set my compass in to 7 centimeters. So I'm putting the pointy bit here. That's 7. This is in millimeters here, but hopefully you get the idea. And that's pretty close there in terms of kind of my 70. You can't really see that, but the pointy bit going from there. And I'm going to do an arc then from B. So hopefully you can see that. And that's what we need. It then says less than 30 from L. So again, I'm going to set things in equal to 3. Let's actually do it here. So hopefully you can see. That's on 3. And that's 3 centimeters there. My compass here. And that's all we need really. It's the 2 bits where those kind of crossed. Shade the region in which the ship could be. And that's my region there. Question 13. Complete the table for y equals x squared plus 3x minus 3. and we got to do it for minus 3 and 2. I always like to make myself feel better by doing the easy number first, which is the positive number. So I'm going to substitute the number 2 into here. So let's see what I would get. I would get y equals 2 squared. So I exchange my x here for a 2 plus 3 times 2 minus 3. That gives me 4 plus 6, that's 10. Take away 3. And so that then is 7. For minus 3, y equals minus 3 squared plus 3 upon minus 3 minus 3. Real common mistake coming up here. Minus 3 squared, remember, is minus 3 times minus 3. That's actually a positive. So that's 9 plus minus 9. So they cancel each other out. So that's 0. And then it's minus 3. Sometimes you're lucky enough with these quadratics. You see the symmetry there? 1 minus 3 minus 5 minus 5 minus 3, 1. And so you can see then where it's going. Draw the graph then from minus 4 to 2. So we need then our wee values here. So minus 4 is 1. So minus 4 is 1. So it's going to be there. Be careful with the scales as well. That's minus 1, minus 2, minus 3, minus 4. Whereas this kind of goes up in 2s. Minus 3 then is minus 3. Minus 2 is minus 5. Minus 1 is minus 5. Again, I'm just reading from the table here. 0 is minus 3. 1 is 1. And 2 then is 7. So we got to draw the best curve then we can. I always find it's easier if it's kind of in the inside of your hand. So I'm just going to turn around again. Remember, it's a paper. You can turn it around whatever shape you want. I'll turn it back around in a wee second. Just whatever way is easiest for you to draw. That's an okay effort, I think. Not brilliant, but it's okay. Finally then, use your graph to estimate x squared plus 3x minus 3 equals 0. So we have the graph of x squared plus 3x minus 3, and we're trying to work out where it equals 0. It equals 0 whenever I change my y for a 0. Where is y 0? It's anywhere here on this axis. And so that looks to me like it's minus 3.8 maybe. And there then kind of a 0.8. I think it's supposed to be symmetrical. So something like that. So I'm going to go for that. Minus 3.8. And then 0.8. Reading off then those values. Question 14. Write the decimal number 15 as a binary number. So the way I normally set these up then is I would have 1, 2, 4, 8 and 16, and I'm trying to make up then the binary number, so I can't have a 16, that makes it too big, so I need an 8. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, so it's going to be 1, 1, 1, 1. Write the binary number 1, 0, 0, 0, 0, 0, 0 as a decimal number, so we need 7 numbers going along here, so it's 1, 4, 8, 16, 32, 64. That is 7 numbers, I think, then, isn't it? So 1, 2, 4, 8, 16, 32, 64. And so it's 1, and then 0, 0, 0, 0, 0, 0. So the number then must be 64. Question 15. An industrial tank has dimensions 10 times larger than the dimensions of a similar domestic tank. How many times larger is its volume? We chatted about this earlier in the paper. If the dimensions, as in the lengths, are in the ratio 1 to 10, then their volumes, we talked about area actually in the last one, are in the ratio 1 cubed to 10 cubed. So that'll be 1 to 1000. So the answer to that then is going to be 1000. Question 16. Tom has some 20p coins and some 50p coins. The total value of Tom's coins is 860. Sienna maybe, has twice as many 20p coins as Tom, but only half as many 50p coins as Tom. The total value of Siena's coins is 820. Find how many of each type of coin Tom has. Trial and improvement will not be accepted. That's a fairly tough one, I think, for us. So let's see, we have 20x plus 50y equals 8. You can write 8.60, but I kind of like getting rid of the decimals and just kind of 860. Twice as many 20p coins. So Tom has x of them, because say we had 4, say I had 4, we would have to do 4 times 20 to work that out. So Siena's going to have 20 upon 2x plus 50, and half as many of these, a half y, and hers, if it, that's the right phrase, comes to 820. So that gives me 20x plus 50y is 860. That's my equation 1. Then my equation 2 tidied up is 40x plus 25y is 820. So there's my 1 and 2. I suppose I could have saved a bit of space there if you kind of knew what was going on. So I'm going to times this one here by 2, I suppose. So I'm going to do 1 times by 2, and that gives me 40x plus 100y, and then 2 860s. Then I think then gives me 1720. And then I'm going to take these two and I'm going to subtract them. So I'm actually going to do this one, take away this one, because I can see it's going to be nicer numbers. So I'm doing 1 take away 2 as you read them. So this one take away this one. That there gives me 75y, 1700, and then that gives me 900. And then we're going to work out how many 75s there are in 900. You can do it a couple of different ways. If you just type times up in 75s, 2 of them are 150. That means 4 of them would be 300. And there's obviously 3 300s in that. So it's actually then going to be y is 12. And substitute into anything then to kind of get the other one. So let's see if we sub in the number 1. $20x plus 50y is 860. 20x plus, so it's 50 then times 12. So 5 12s are 60. So it's going to be 600 equals 860. That means 20x is going to be 260, and that means x then is 13. Find out how many of each type of coin Tom has. So as Tom was started with, so he then has 13 20p coins, and he has 12 50p coins. Tough enough one, that. I think that wee bit is really quite tough in terms of our simultaneous equations. But that's what we have. Exercise 17a, the lines y equals 2x plus 1x plus y equals 4 have been drawn on the grid. So that's there. By drawing another line on the grid above, indicate clearly by the letter R, sorry you can't see that, the reason satisfying y is greater than or equal to 2x plus 1, x plus y is less than 4, and x is greater than or equal to minus 1. So we need to draw on the line using this one here. So that's going to be the line x equals minus 1. The line x equals minus 1, let me see, is going to be this line here. So that's that line, and we need to see then which bits we're looking for. So we want x is greater than minus 1. So I know it's going to be that end. So I don't want this side. So this is the bit I'm getting rid of. I'm going to finally label it that. X plus y is less than 4. So that's this line here. I know. And I guess with a bit of practice you can kind of see why. So I know because x plus y is going to be less than 4, I know it's going to be below that line that I want, so I'm going to get rid of above. because it's less than, more or less. There's a few exceptions to that. The other thing you could do is pick a point not on the line and see if it kind of makes sense if it's on it. So there's a point not on the line, 1, 1. Substitute 1 and 1 into this. 1 plus 1 is 2, and that is indeed less than 4. So that side's good. Y is greater than 2x plus 1. Gradient of 2, y-intercept of 1. So it's that line there, and we want above it. Again, if you're not sure, pick a point not on the line and check and see if it's true or not. And so the region that we want is that one. Part B then is a very similar question. It says, by drawing more lines on the grid above, indicate clearly the letter B, the region satisfying this. So we have this one then is the x plus y is less than or equal to 4, so we want below that, but we need to draw our lines first. So we're going to draw the line y equals 2x. You can either know gradient 2y or going through the y, or going through 0, 0, or you could pick some numbers at work. If you have x equals 1, then y would be 2. Do you see what I'm getting at? Subbing in 1, you get 2. X is 3, just for example. Y then would be 6. So as you plot those, it would look then like that line there. So that's the line y equals 2x. Excuse me while I turn this round here to get this drawn accurately. So that's the line y equals 2x. The other line then is y greater, so we're going to do y equals 1. So that line is a bit more straightforward. It's the one where all the y coordinates are 1. And we have that, so that's the line y equals 1. Similar to the last thing we've just kind of chatted about, we want y less than or equal to 2x. So we want below this line, so I'm going to get rid of above it. Again, pick a point not in the line if you want to do it that way. X plus y is less than 4. We want below this line. And then y is greater than 1. We want above this line. So it's that wee tiny triangle just in the middle there. And they've asked us to label it B. And that's us done.